Hi everyone, today we are going to see a pong game, so using 8266. This is a continuation to the previous section that we have did, so let's get started. If you are new to the channel, please subscribe, like and share. So this is the board. It's similar to Arduino Uno, so the pins are mostly compatible, but there are minor changes. So on the connection front, so everything is connected to the SCL and SDA. So whoever using node MCU, so that is also put in place. You can connect the MPU 6050 using this connection diagram. So first connect the LCD. So you can see I am connecting using a breadboard. So it consists of 4 pins: VC, ground, SCL and SDA. So then connect the MPU 6050. So I am just connecting them in parallel. You can see the pins align. So if your board is not aligned, you can use jumper cable also. So like you said, right, so VC is connected to directly VCC. So both modules are having the same, the pins are oriented in same order, so I just put it in a single rail. So now we are connecting the board with the power. So the plus 3.3 volt goes to the VCC. You can use 5 volt also, that is also fine. So I'm just putting it in 3.3 volt. So I'm just putting it in the first pin, so which is the VCC. Second is the ground, so just connect the ground. Okay, so once you connect the ground, put it to the second pin. So as mentioned, the second pin is ground. So I'm just keeping it aside. So then we have to connect the SCL and the SCA. So both are data pins. So I'm just putting it in this. So it is similar to Arduino. So if you have Arduino also, this should work. So let's keep it this way. So next goes the SCL pin, that is the clock, then the data pin. So 4 pins basically: VCC, ground, SCA and SCL. So I have connected both of them, then connect the USB, then we are good to go. So the similar connection should work for any compatible boards. If you have a different layout board of ESP8266 like Node MCU, this should also work. Refer the connection diagram. Now go to device manager. So first we have to look into the COM ports are fine or not. So once you connect the board, it should show under the COM and the LPT ports. So now it is not showing, right? So just right click and scan for hardware changes. So if you are connected, if you have installed all the drivers, it should show. So just wait a bit. So you will have the port shown, like in this case COM 11, right? So like that it should show. Otherwise you have to install the drivers properly. So once that is done, then go to the board manager. So you have to select the board and the port. So I have selected it properly. Consider it, go to the board and select ESP8266. So it is compatible with both Uno as well as ESP32. You can use any of those as well. So now look into the code. So this is this code, right? So the whole thing is to check whether the devices that we have connected, right, that is showing properly or not. So we have a simple loop which goes through all the addresses and check if there is any available device. So if it is there, then it is going to print in the serial. So nothing fancy here. So it is just to check whether the code is working or not. So now we are uploading it. So once it is uploaded, we just to open the serial port and see whether the two devices that we have connected, the OLED as well as the IMU, shows in the console. If it works, then we are good for this part. So you can see it is showing the two devices 3x and 2c. So both of them are addresses of those devices. So let's see how to read the IMU. So for reading the IMU, so first we have to declare the gyro address. Then we have to create some variables. So I have created these structures. So basically it's like a class for in C. It holds all the in a 16 bit integer format, because the data is stored in a 2 complements format. So we can't use it the normal int. So you can see in the right side that it shows, right? So the data is stored in 2 complement format. So that only we are using int 16. So here we are beginning the serial and initializing the MPU. So there are registers to set the configuration for the IMU. So that's happening here. So this is available in the data sheets. So in the comments I have made it how it is set up. So basically it is to select the sensitivity as well as the scaling factor, and also there is a filter basically to have a low pass filter to filter out the noise. So we have basically we have to write it to this particular register with the particular value. That's where the two write command for each section comes into play. First we have to write the register, and then we have to write the actual information to that register, then in the transmission. So once this is done, so this will initialize the MPU properly. So then let's move on to the loop. So our in main loop, basically what we are doing is we are fetching that information. So how it happens is there is a function called update MPU values, like you see, right? So in the update MPU values, what we are doing is basically we are telling beginning the transmission for that MPU. So we're using the gyro address. Then we are writing the 3B, which gives us the registers to start reading it. Then we request a data of 14 bytes. So each 2 byte is axis. So the axes are in a particular sequence. So first it will have the accelerometer data, then it will have the gyro, the temperature and the gyro information. So we are reading it twice so that we get the 2 complements number. So first the most significant bit, then we shift it to 8 places to the left, then we are adding the another 8 bit, so we get a full 16-bit information that is stored in a X variable. So we do this for every channel so that we get the full information. So this is how it is. Then same goes for each of the section. So then so once that is done, then we will go to the yaw pitch. Basically we will, using this information, we will calculate the yaw pitch and roll. So how it is done is, first we will calculate how much distance has been traveled for a particular cycle. So we are looping this main loop in about 250 times a second. That's the 250 hertz for each degree turn. So the gyro will give us the output of 65 point. So that we just converting that information for each cycle, it will return about 0.006 degree per cycle. So basically, so what it will do is we can simply multiply it with the output so that we get how much angle we are moving the along the x-axis. So that's the pitch. So same goes for the roll. So this is again the 65.5, right? So that comes from the data sheet. You can look it through. Then what we are doing is we are linking the pitch and roll, since moving one axis also influences the other axis. So that is done by a relationship called sine. So basically when we are moving the pitch angle, so the roll is also changing. So the relationship is nothing but the sine of that particular distance. So that has been calculated using sine function. we just multiply it, so that for pitch we are minusing it, for roll we are adding it, so that if one axis moves, then other axis is also adjusted accordingly. This is just a limit to exclude the noise as well as the other information that we don't need. So it's just a limiting condition. So now we are calculating the actual pitch angle as well as the roll angle from the acceleration. So now we are doing it using the scale factor. So since we are selected that from the data sheet, so that has been mentioned here. So the 50.725 is nothing but the radians to degrees calculation for each radian. So it is 57 degrees. So we are multiplying it to get the actual angle, because the ascent function returns in radian. So then we are taking 90% of the gyro information, and for 0.004% of the acceleration information, because we don't want the noise of the accelerometer to ruin up our values. So then we are printing it on a loop basis. So we are not printing it for each cycle, we are printing only one for every 50 cycle, we are printing once. So if it is not 250 Hz, then your system will wait using this while loop. It will not do nothing until the time is passed. So the whole cycle continues. Then we are compiling this. So once we upload this, we will see the output. Again, so there is a good example. If you are not understanding this properly, you can use Adafruit MPU6050 library as well. So once it is uploaded, just go to serial monitor or serial plotter. You can see. So we have to just change the baud rate. I'm just changing it. You can see it is printing all the pitch, yaw values and the roll values that we have calculated. So, and also the raw accelerometer as well as gyro information. So if you want to see it in a chart format, you can again go to the serial plotter as well. So this will give you in a plot format. So you can see the each axis how the data is. So when you start move the board, it is going to show up. So again, so you don't have to go through all of this. What you can do is you can download the Adafruit MPU6050 library, then use their function. So it will give you the nice the same output what we have done. So you don't have to think about all the overheads. Okay, so you can see the pitch is being adjusted if you move the board up and down. So let's see how it is. So finally the game code. So the game code is pretty simple. So we are using Adafruit's the graphics library. So we are defining the screen width and the screen height as well. So the screen address, we are creating the wire class for it by passing these parameters. Then there are previous parameters that we have seen from the gyro example. It's the same thing. So idea is that we read the pitch information, then input it to the actual paddle that you see on the game. So it will move the pitch, will move the game's paddle so that it controls the ball. So that's where this paddle X and paddle Y comes into picture. So again, this code is also available from Arduino site. So this is a modified version. So you can feel free to read this through. Right, so then we are clearing the display. So setting the logo. Then we wait for 2 seconds. Then we increment the loop counter, then we read the MPU values and calculate row yaw pitch value. Then we transform the pitch information into the paddle movement using this map function. So we are not using paddle Y, so that is stationary, so that we don't have to worry about it. So it will fix in the bottom, the control is in one axis. So then we are drawing the paddle. So that's it. For each and every cycle we just calculate this paddle x and paddle y by using the pitch. When we move the pitch, so it is going to move the paddle in that particular position. So that's how the paddle control works. So then updating the old paddle x paddle y for the next iteration. So in the move ball is basically for each cycle or each frame we are just adding some direction in x-axis always as well as in y-axis. So that is going to move the ball in either one of the direction. If it hits the side of the screen as or at the paddle that we have drawing, so then it is going to change the direction. So that's how you get the bouncing effect of that ball. So basically this if condition checks for the collision between the paddle, so that we'll be able to run this. So it will return a boolean based on that whether it is touching it or not. So based on that we are good with this. So let's upload the code and see how it works. Again, so these two libraries, right, so MPU6050 as well as this game code that you see, right, both are available for Arduino in Arduino's official site as well. So this is a modified version that suits for this use case. You can feel free to change it to your need. The code is in the description.